Hello guys, welcome to a new video, and this is the continuation, and this is going to be part 3 of the video series. And if you guys have not watched my other two videos, I suggest that you guys go to my YouTube channel and watch the first part, which is this one, the one that we configure EIGRP and TACAS, and then also the second part. I know they're a little bit too long, but I have lots of fun, so go ahead and watch it. This is the part 2 of the video, and this one right now is going to be the part 3 that I'm going to configure now. And let me give a shout out to my latest subscriber. Look at this guy, said thanks, not thank you. And we have a new subscriber, which is Piz Amy. Thank you for subscribing. Mohammed Adeng Hamdi, thank you for subscribing. Juan Ruiz, thank you for subscribing. Welko Pong, thank you for subscribing. And Rahman, thank you for subscribing. So if you want to keep um, getting my videos, my latest videos, just go ahead and subscribe to my channel. And let's go ahead and start with this lab. And in this lab, we are going to configure some unequal loan balance. We are going to also do some roadmaps and set up the next HAP address. And also, we are going to do some EIGRP authentication. So the first thing that I want to do is um, first thing I want to do is we're going to configure the bandwidth for these interfaces and also the bandwidth for this interface, and then we are going to do EIGRP authentication. After that is done, what I want to do is I want to do that on equal load balance, and then we are going to do that roadmap. Okay, so let's go ahead and I'm going to use the microcore Linux computer so I can remote into every single router because today I'm working from home, let's say, and I'm going to log in with my micro Linux computer. I'm going to VPN to my work, and then I'm going to go into this router so I can configure it. So let's go ahead and open my micro Linux computer. And remember in the video before, we configure loopback addresses for each one of them. So I know which one I could telnet to. So I'm going to telnet to 1.1.1.1, which is router 1. And let's go ahead and do a DNS3. And this is authenticating using TACAS. So if you haven't seen my videos, go ahead and watch it so we can configure TACAS. Okay, so now I'm logged into router 1. The first thing that I want to do is change the bandwidth for gigabit 01. So let's go ahead and do that. Let's set the bandwidth to be 64. Let's give it a shutdown. And then let's go ahead and remote into router 2. So let's go ahead and do telnet and telnet to router 2, DNS3, DNS3, enable Cisco as a password, config T. Let's go ahead to the same interface. Let's just shut it down first. Give it a bandwidth of 64. Now shut down and let's save this configuration. Okay, now let's go ahead and exit. And now we're back to router 1. And from router 1, let's go ahead and do config T, interface gigabit 01, and now shut down and show IP route. And let's do, we see too many. So show IP route. I just want to see the EIGRP routes. There we go. So that's a lot less. And it looks a lot better. So from over here, this is what we see. And if we go to show IP, EIGRP, I believe it's topology. Yep, to topology. And if we see that the routes, we have a lot of routes right here. And the routes, if we go to, let's see the one, so everything that is going to the OSPF, like the 4.4, is going to go via 172.16.6.2, which is gigabit 00, because the bandwidth is a lot better than gigabit 01. Okay, so later on, what we want to do is we want to send the via this 4.4.4.4. I want to send the via 172.16.5.2. So that's what we're going to do later on. For now, we're just going to leave it like that. So let's go ahead and telnet 2.3, 3.3.3.3, enable Cisco config T, and let's configure the bandwidth for this one. Interface gigabit 00. Let's just shut it down. Bandwidth 64, no shutdown. Okay, and let's save it. Then after that, from router 3, I want to telnet into router 1 or router 4 and configure that bandwidth as well. GNS3, enable Cisco config T, interface gigabit 0/0. Let's just shut it down. Let's give it a bandwidth of 64. Now shut down, and let's go ahead and save it. And later on, since everything is going to go via gigabit 01, it's not going to be load balancing anymore because this bandwidth is a lot lower than gigabit 01. We are going to configure unequal load balancing, but that's going to be later. So let's go ahead and exit, and then exit. And now we are back to router 1. And for router 1, I want to configure authentication. So what's going to happen is I'm going to configure a key, and I'm going to assign the key to the interface, and then that is going to bring down the interface. So if you do ping 172.16.6.2, you see we're able to ping it. So let's go ahead and create a keychain first. Let's call it asker. Or actually, let's exit out of here. Um, the keychain that I want to create, let's say no. I want to create a keychain, and let's call it router 1. The key ID is going to be 1, and the key string for this one is going to be 1 and 2. So from router 1 to router 2. And I'm going to now assign it. We'll still be able to ping that interface, good. But after I assign it to gigabit 0/1, we're still going to be able to ping it because we're going to send it via gigabit 00. That's what's going to happen. So let's go ahead and interface. And from here, IP authentication, mode EIGRP, and the EIGRP is 10, and we're going to use MD5. Let's see if we're able to ping. We're still able to ping because we are sending it now via gigabit 00. And then after that, let's do IP authentication, key chain EIGRP, EIGRP 10, and then we have to do that keychain string, which is 1, 2. Not actually, it's not 1, 2, it's rather 1. Sorry for that, guys. So now after that, let's go ahead to gigabit interface 00, and let's assign IP authentication mode to be 10, and now we shouldn't be able to ping. We're still able to ping it. So we went to gigabit 00, we assign authentication, and gigabit 01, we assign authentication, but we're still able to ping route 2. Let's go ahead and configure authentication, which one was the one that we assigned. So we assigned IP authentication mode. Okay, now let's do the keychain and call it R1. And we're still able to ping 172.16.6.2. Let's go ahead and show IP, IGRP, neighbors, do. So we don't have any neighbors, Um, so the neighbor relationship went down, so we shouldn't be able to ping then that three, let me see, that three, that two neighbor. So we're not able to ping this interface. So we're able to ping this interface because they are directly connected. Okay, and that's what's happening. And also we see that we do not have neighbors. So we have to go, let's go ahead and end it, save it, and let's go ahead to telnet to router 2 so we can fix this. So it is unreachable, so we need to go to 172.16.6.2, DNS3, DNS3, and we won't be able to authenticate using TACAS either, so we need to use our local account, and I believe the local account, I set it to probably my name and Cisco. There we go. Enable Cisco. Now we are remoted into router 2. So after that, we need to do config T. Let's go ahead and create a keychain and call it asker. Or let's call it just router 2 so we can stay with the same configuration. And then let's do the key ID is 1 and the key string needs to match. So it's 1, 2. Then let's go ahead to interface gigabit/1 IP authentication mode EIGRP 10 MD5. And then IP authentication keychain EIGRP 10, and then we have to do that key chain, which is R1, or actually R2. Now we should have a neighbor relationship. So do show IP EIGRP 10 neighbor. There we go. We have formed a neighbor relationship with router 1, which is right here. And if we go in, actually let's go ahead and configure interface gigabit/1 or 0 as well. And let's go ahead and do keychain mode and then the keychain EIGRP 10. And now we should be able to have more neighbors. As you can see right here, we have neighbor 5 and neighbor 6. And those are for R1. So we are authenticating now with um, we are authenticating between R2 and R1. So this is working great. And now if we do N-WR to save it, and then we're going to exit and go into R1. And if we go back and telnet, we should be able to telnet with its loopback address. And we should be able to use now the two-way authentication. There we go. So it is working. That is great. So let's go ahead and exit. Actually, let's go ahead and turn it back to it. I'm sorry for that. DNS3, DNS3, enable, um, enable Cisco, config T. And now what I want to do is I want to create another, let's create another keychain. And this keychain is going to be attached to um, this one over here. And now let's just keep the same keychain and let's just use it between R2 and R3. And if we do a do show IP EIGRP neighbor, you're going to see that we have this neighbor right here. But after we configure gigabit/02 with the authentication, it won't be able to have that neighbor relationship anymore. So you're going to see that. So let's go ahead and configure interface gigabit/2 with IP authentication mode EIGRP 10 MD5 IP authentication keychain EIGRP 10, and the keychain is R2. Okay, so now if we do a do show IP EIGRP neighbor, you see right here that the neighbor is not there anymore. It was over here, but it's not there anymore because we need to configure we need to configure R3 to use EIGRP authentication, and the key strength needs to match with R2, which is 1, 2. So let's go ahead and end it. Let's go ahead and save it. And for R2 now, if we try to turn it to its loopback address, to router 3 loopback address, we won't be able to do it. So we need to turn it using its um, directly connected IP address, which is 72.16.3.1, 172.16.3.1. And we cannot use TACA, so we need to use the local account, which is Asker, and the password is Cisco. Enable Cisco. So config T. Let's go ahead and configure that key chain. Let's call it R3. Key ID is 1, and the key string needs to match, which is 1, 2. Now let's go ahead to interface Gigabit02, IP authentication, mode, EIGRP 10, MD5, IP authentication, keychain, EIGRP 10, and the key string or the keychain we need to call is R3. And it is case sensitive, so make sure that if you put an R, capital R, it needs to be a capital R or lowercase r, lowercase r. Now we should be able to, if we do N WR to save it, or if we do show IP EIGRP neighbors, we should have a neighbor with a 3.2 network. So this is great. Now we have configured these 3 interfaces with authentication. So now let's go ahead and end it and configure these 2 over here. So config T. Let's configure interface Gigabit01, and it's going to have this mode and this keychain. Okay, so now if you go ahead and end it, show IP EIGRP neighbor, we should see that we do not have any relationship with on this interface because we configure authentication. So let's go ahead and go back and configure Gigabit 00. And over here, let's go ahead and do the mode, and then let's go ahead and do the keychain and show IP EIGRP neighbor. Now we only have one neighbor, and this one is router 2 because we actually configure authentication over here. So now we need to go to our, let's go ahead and save it, and we need to go ahead to router 4. And like I said before, you cannot tell it using the loopback address because we do not have EIGRP working. So we have to use the local or directly connected IP address. So telnet 172.16.1.2, and we need to use the local account because TACAS router 4 cannot reach TACAS since it does not have any relationship with router 3. Okay, enable config T, and then let's go ahead and create that keychain right away, and let's call it R4 key ID 1 key string needs to match, so it's 1 2. Now let's go ahead to interface gigabit 0/1 IP authentication mode. The mode is EIGRP 10 using MD5, and then IP authentication keychain EIGRP 10, and we are going to use the keychain R4. So now we should be able to have one error relationship. So if we do show IP EIGRP neighbor, there we go. So that's great. Now let's go ahead and configure gigabit 0/0 mode, and then the keychain. Oops. Let's go ahead and say no. That's the wrong one. And let's do it again. There it is. So now do show IP. There we go. So now we have formed a relationship. So that's great. And save it. Let's go ahead and exit. Go back to R3, exit, and go back to R2, exit, and go back to R1. So we have configured the bandwidth on these interfaces, And we also configure EIGRP authentication for 1, 2, 3, 4, 5 links. So this is great, guys. So now let's go ahead and exit to go back to my computer. And then after go back to my computer, I want to remote it into R. Let me see. I want to remote into R3. So we can do telnet 3, GNS3, GNS3, enable Cisco, show IP, route EIGRP. So now what I want to do is, as you can see right here, let's go ahead to what I want to do. Let's do a show IP EIGRP topology to see it better. What I want to do is I want to configure. Let's see. So this one seems like so everything. Okay. So this is R3. Hmm. Let's go ahead and show IP routes EIGRP. So is there show IP EIGRP neighbor? So we have a neighbor for these two. Okay, now let's go ahead and exit and let's go ahead and telnet to router 4. DNS3, DNS3. Put in the wrong password. So, so let's try it again. DNS3, DNS3. Show IP, show IP route, then EIGRP. Okay, then show IP, EIGRP topology. Okay, and as you can see right here from router 4, you can see that we the 64 bandwidth gives me this the physical distance for 10.10.4 is this one right here. So what I want to do is I want to do a what is called variance, and when that happens, it's going to make this physical distance um, big enough so I can match this physical distance right here. And when this physical distance is match, when this physical distance match this one, then we can do a load balance. So I shouldn't have put 64 because 64 is a little bit too far for the physical distance. As you can see, it's a little bit too big. So for gigabit interfaces, what is the bandwidth of a gigabit interface? Let me see something. Bandwidth of a gigabit. So it is this. So actually, if we go to, let's go back, we can figure it out from here. If we go and do a show IP interface, let's go ahead and do interface gigabit 01. We should see the bandwidth, right? And the bandwidth is not here. So it is show IP or show interface. So the bandwidth is this much. So what I want to do is copy so we can make our life easier. Let's do a calculator. And where my calculator go? Okay, so over here. So let's bring it back. So this divided by 2. So this is what I want to set my bandwidth to because that's going to make more sense. So let's go ahead and config T and go to interface gigabit 0/0. And let's do bandwidth of this, and let's go ahead and save it. Um, Exit, turn it to router 3. Run password, config T, interface gigabit 0/0. Just give it a bandwidth of this and show. Actually, let's go ahead and turn it to router 4, GNS3, and let's go ahead and do show IP EIGRP topology. And now you can see that the actual physical distance is actually a lot lower than before. So we want to keep it like this. And then we're also going to have to do it over here too. So let's go ahead and do bandwidth of this. And then let's put over here bandwidth of this. Okay. So what we want to do is let's go ahead and configure unequal load balancing. So let's go ahead and save it from here. And what you want to do is configure unequal load balancing. And the way to do it is you have to go to config T and then go to router EIGRP 10, and you need to configure variance, and we want to do it too. So N and then show IP IGRP topology, show IGRP topology, and as you can see, for if we want to reach the 2.2 network, we have to go to gigabit 00 and 01, and so it looks like the variance. Did I do it right? I need to do it either from router 4. Let's go ahead and do it from router 3. So let's go ahead and save it and go ahead and exit. So router 3, config T, router EIGRP 10, variance of 2, and show IP EIGRP topology. Okay, so yeah, we need to do it. It's not from here. We need to do it from router 4. So let's go ahead and do router EIGRP 10, no variance of 2, and let's go ahead and save it. Turn it to router 4, DNS3, enable show IP EIGRP topology. So the visible distance is still it still did not go up. So let's go ahead and config T router EIGRP. EIGRP 10, variance 2, let's say no. Let's just do a variance of 3. Show IP EIGRP topology. So now the visible distance for this one, did it go up for 168.1.0? Let's go ahead and look that 168. 6144. So for gigabit 01, let's see. Okay, so we have two. So it looks like we have two successor. So let's go by that. But let's go ahead and do config T so we can router EIGRP 10, as you know, variance of 3. And then let's go ahead and do show IP EIGRP topology. Okay, so now as you can see, we have one successor and one successor. So that means that it's only going to be using gigabit 01. But when we configure variance of 2 is we are going to have two successors. So that means that it's going to use two interfaces. So let's go ahead and configure variance of 2. So we can have two successors. And do show IP topology. And as you can see now, for most of them, we have two successors. For the 10 network, two successors for the 5 network, two successors for the 192.168.1 network. And before we only had one successor, one and one for most of them, but now we have two successors, and that means that we're doing unequal load balancing. Okay, so that's what I wanted to do. That's great. Let's go ahead and save it. I got confused a little bit. Not confused, but lost on how to explain it to you guys, how the variance and how unequal load balancing works. So that's saved. Let's go ahead and exit out of here. Now we're back to router 3. Let's go ahead and exit. So now what I want to do is I want to do, if we do a ping to the 3 network, let's do a trace cert. Is it trace cert? 3.3.3.3. Now found trace route. There we go. So now as you can see, when we do a trace route, when we want to ping this router over here, the 3.3.3, it is going via my default gateway, and then it's taking and then it's going 172.16.6.2, so it's going via gigabit 00. Okay, so what I want to do is I want to send it via gigabit 01. So let's go ahead and configure that.